Hello, this is Chennan. Today I am here to demonstrate our group project, which is on decision rules LARS. LARS stands for Learning from Examples Using Rough Sets. This is a Java project. In this project, we are going to calculate certain and possible rules and classify data. This is our project folder, and this is our main code here. And these are the input data files which we will be using, and this is the output for we'll be getting the output data, so we can access those files from the IDE also. So this is attribute data file and this is attribute values file. So here we are going to get the data from the attribute.txt file, and here we are going to get the data from the data.txt file, and we'll be assigning values to the attributes here, this code. And also here's the main code block where we define our rules, calculate certain rules and possible rules here, and also combine possible rules is one of the most important one, where this function is used to combine attribute values, which will be used as an input for the next loop in the LARS algorithm. So now I'll be executing our code. So these are the attribute values. We should type any attribute value from this. Right now I have selected C and press enter. We'll be getting an output here. This file is automatically saved in our folder. So in loop 1 we'll be getting attributes and corresponding attribute values, which is data. So these are the all possible values. Uh, for these attributes, these are the certain rules and these are the possible rules. Certain rule is nothing but the proximity of having close similarity with the decision attribute. For example, A2 has x1 and x5 in them, and C2 also has x1 and x5 data in them. So the support is 2 and confidence is 1. So possible rules are nothing but dissimilarity. So G1 has x2 and x4, whereas C1 doesn't have x2 and x4. So that's where the support is 1 and confidence is 50.
Hi, this is Jawahar Reddy. Now I'm going to explain about RSES software. So RSES is a toolkit for analysis of table data based on methods and algorithms coming from the area of rough sets, which are also known as the data sets. It comprises of two general components, the GUI front end and the computational kernel. So now we are going to create a table. So in this table, we have to insert a sample data. So these are all the data sets. So now we are going to take a sample data set as diabetes. So here we have loaded the diabetes data set into this table. So now this is all the data which is in the diabetes data set. So now for this data, we can look into the statistics. So this table has 9 attributes. So these are the 9 attributes which are shown here. So the attributes are divided into two types. One is condition attribute, and the other one is decision attribute. So here the top 8 are the condition attributes, attributes, and the class attribute is known as the decision attribute. So based on these 8 attributes, so the decision can be made whether a patient has diabetes or not. So we can also split this table into two parts. So here, while splitting, we will get a split factor. So here, 0.5 split factor means we are going to split the table into 2 equal halves. So the 50% of the table, the data will be contained in the first table, and the remaining 50% data will be in the second table. So if we click on OK, so these are the 2 tables which are which we get from the parent table. So these tables contain the equal number of data. So for this project, we are not going to do any split. So I'm deleting it. So now we can generate the rules for this table. So we have to select the option rules here, and we have 4 methods which we can use. Any one of the algorithm we can use it. So the first one is the exhaustive algorithm. So in this algorithm, we use the brute force method. In the brute force method, we will do the trial and error process. So in the generic algorithm, a method for solving both constrained and unconstrained optimized problems is used. So that is based on the natural selection. The generic algorithm repeatedly modifies a population of individual solutions. So the third, we have the covering algorithm. So in the covering algorithm, the context of proposing learning system is an algorithm that develops a cover for the sets of positive examples. So in this algorithm, it only takes the positive examples and it ignores the negative examples. So finally, we have LEM2 algorithm. This is an algorithm which is used for decision rule induction from the data. So after choosing an algorithm, so here we are using the exhaustive algorithm, which is the default one. So after that, we have to select a set. So we have, as we loaded the diabetes set into the table, we are selecting it. Okay. Yeah, now this is the rules. So these are the decision rules for our table. So the first rule has been matched 18 times, and the second rule matched 17 times, and so on. So these rules have matched 3, 4, 5, etc. Based on the data. Now we'll classify the data in this table. So we have to select the generate confusion matrix, and this is the data set we have selected at the beginning, and this will result to the diabetes table. Yeah, and now we have to click on OK. Now we got the classification. If we see the classification, so there are 268 objects in 1 and 500 objects in 00. So this means that 268, based on the rules, 268 people has diabetes, and 500 people do not have diabetes. So number of objects are 268 plus 500 in total. The accuracy and coverage is 1 each. So after this, the final step is we have to make the decision tree. So these are the default values. Now we can click OK. So we have the decomposition tree here. So here we can see we have a parent node. So this is a root node. It is split into two parts and so on. So here this is the root node. The size of the table is 768. It is showing. So the root node is divided into two parts. So the one part is has 2 hours of serum insulin greater than or equal to 32, and the second part is less than 32. So of all the data, greater than or equal to 32 is divided into one half, and less than 32 is divided into other half. So like this. So in this node, the parent condition has to satisfy. As we can see, 2 hours of insulin greater than or equal to 32 and plasma glucose concentration greater than or equal to 120. So this is the parent node condition, and this is the particular node condition. So if you see this node, it also has the parent node condition, and it also has its own condition. So based on these conditions, we get the nodes. So there are 15 nodes totally, one root node, and these are the remaining nodes. So finally, if we take the data into the table, we can do the we can do the rules classification and decomposition. So this is a decomposition tree, this is the classification, and these are the rules. So based on these rules, classification is done. Based on these rules and classification, decomposition tree is made for the table. Thank you for giving me the opportunity to